Hello! Welcome to Petals for Your Troubles. We thank you so much for the positive reviews of our first physics video ever. And since you dedicated followers of this channel love physics, let us introduce to you a new physics concept. Earth is an amazing place to live in. When you throw a ball upwards, it would reach a certain height, then come speeding right at you. There could be a police pursuit right on your streets, trying to catch a criminal right at your neighborhood. And when you do not pass your assignments, your teacher will be running for you as fast as he can. And what do these events have in common? Well, they accelerate. So today, you will be learning about Newton's second law of motion, which is the law of acceleration. Since we know that force net equals mass net times acceleration, we can rearrange the equation such that we are finding for acceleration. It becomes acceleration equals force net divided by mass net, or A equals F net divided by m net. So by definition, by looking at this equation, acceleration is directly proportional to the net force and inversely proportional to the mass of an object, or objects. It is also important to know about vector notations. Vector notation in terms of acceleration are scalar components of an acceleration. In 3 dimensions, these scalar components are the x direction represented as I hat, the y direction represented as j hat, and the z direction represented as k hat. There is a similarity between coordinates and vector notation. Let's take a line drawn from the origin to the coordinate -2, 5. The coordinate says that the line is moved 2 units left in the x direction and 5 units up the y direction. Vector notation, however, we use the plus symbol. So, the vector notation of this line is -2i hat plus 5j hat. Since the line is not moved to the z direction, this line is drawn in 2 dimensions. Now, let's solve a problem.
There is a raft at the sea. There is a man in it, and the total mass of the man and the raft is 1,300 kg. Using his pedal, he produces a force P of 17 Newton I hat. The wind also exerts force which we call force A on the raft with a magnitude of 15 Newton and 0.67 degrees north of it. Ignoring any resistance from the water, find the raft's acceleration and express it in a vector notation.
So the given is m equals 1,300 kilograms and 17 newtons. We ask this acceleration. Now to solve this, we need to find the net force of this problem. It will be easier to solve it using a diagram. Since this is a force that is pointed at the x direction, we need to solve for the x direction and the y direction components of. Using simple trigonometric functions, SOHCAHTOA rule, we can find them.
Ta-da! You found the acceleration of the man and the raft. Of course, we do not expect you to know it with watching this once. Feel free to repeat and pause the videos when necessary. We hope you to enjoy and learn something from this video. Please like and share and subscribe for more educational and entertaining physics videos. Goodbye.